Today we're looking at differentiating powers when we've got a fractional index. So what we're doing with these is pretty much exactly the same as what we've been doing before, except we just need to be very careful when we're working with fractions. So remember, when we've got a fractional index, it's like having the root of a number. So if I have y equals x to the power of a half, that's the same as having the square root of x. Okay, so a half, when you've got a 2 in the denominator, it's a square root. If you've got a third, a 3 in the denominator, then that's a cube root. Okay, so there'll be a bit of manipulation back and forth between the radical, so the third form, and the fractional index form. So let's have a look at a couple of questions. So we're going to differentiate the following expressions. So with the first one, so just another reminder, when we're differentiating, if I have y equals x to the power of n, then the derivative y dash or dy dx is nx to the n minus 1. So you bring the power down and you minus 1 off the power. So that's exactly what we're going to do with these. So we've got y equals to x to the power of 1/3. So we're going to take that 1/3, we're going to bring that down, so you can see the 1/3 here, and then we're going to minus 1 off of 1/3. So 1/3 minus 1 will give us negative 2/3. So you can see that power there, negative 2/3. Now when I've got an expression that looks like this, I can also write it back into a fraction so that we don't have a negative power. And I can also change it so that I'm using a third. So if I get rid of that negative power, what I can do is I can write it as 1/3 x to the power of positive 2/3. So that's another way that we could write this result. And then furthermore, we could take this and then write it as a third. So the 3 in the denominator means that it's going to be a cube root, and then the square stays inside on the x. So it's 1/3 times the cube root of x squared. So just be very careful with those numbers that you don't stick them too close together. In question B, we're doing a similar thing. This time we've got a number in front, and we know that if I've got a constant in front of an x, I just leave it there, and I differentiate the x. So the 4 stays there. Then when I'm looking at x to the power of 5/4, I'm going to take the 5/4, bring it down to the front. There it is. And then I'm minusing 1 off the power. So 5/4 minus 1 gives us 1/4. So if we simplify the numbers, we get 5x to the power of 1/4. Or if I want to write that back in third form, it's 5 times the 4th root of x. Okay, so just make sure that 4 is tucked away inside of that tick symbol. With our next question, I've given you the question as a third already. So what we need to do is we need to change this back into index form. So when I'm looking at 1/the square root of x, that's the same as 1/x to the power of a half. So that's sort of where we want to start from. And then because it's in the denominator, we could then write that as x to the power of negative a half. So we kind of need to do all of that working first before we can start the differentiation process. So we've worked out what our x looks like as a power, and then when we differentiate, bring the power down, so I've got the negative half, minus 1 off the power, and that's negative 3/2. So make sure leave those as improper fractions, because as an improper fraction you can then split it as a third with a power inside of it. Now with this, again, we can change our different formats. So if you left it like that, perfectly fine. But if a question said to show that it's equal to something, you will need to show all the steps to get to whatever result that they've got. So what we can do here is if I want to get rid of the negative power, then the x goes into the denominator. And then what I can also do is change the 3/2 into a third. So the 2's in the denominator, so that's a square root, x cubed. So all of those three are valid solutions for this question. When we look at question D, we've got x cubed and then x that's inside of a square root. So what we're going to do here is we want to combine those x's together into the one result first. If I write the square root of x as a power, that's x to the power of a half, and you can see here we've got two numbers with the same base. Two numbers have the same base, we're going to add the powers together. So 3 plus a half gives us x to the power of 7 over 2. So if you need the working out, 3 plus a half, so that's 3.5, or we write that as 7 over 2. Once we've got that, we then need to differentiate it. So make sure you don't forget the core process that we need to do. All we've done here is just rearranged y. Now we're working out the derivative. So y dashed, we're going to bring the power down, 7 over 2. And if I minus 1 off the power, it turns into 5 over 2. So again, just be careful with those fractions. So we can write this as one fraction. So if I've got x to the power of 5 over 2, it's like over 1, and we're multiplying those. So 7 times x to the 5 over 2, or another way of writing it is the square root of x to the power of 5 with the 7 in front, and then your denominator is just 2. So again, either of those solutions is fine. Question E is a very similar example, but this time it's in the denominator. So it's just a little bit more rearranging that we need to do before we differentiate. So the first thing I would do is write the fourth root of x as a power. So that's x to the power of a quarter. And then we've got x to the power of 1 and x to the power of a quarter. So we're going to add the two powers together, and that's equal to 5 over 4. Because it's in the bottom of a fraction, then what we need to do is, if I want it as x to the power of something, it would be a negative power. Once we've done this rearranging, then the differentiation is just as normal. So we're going to bring the power down, which is there, and then we need to minus 1 off the power. So just be very careful when you're subtracting 1 from there. So it's minus 5 over 4 minus 1, and that's going to give you negative 9 over 4. Again, you might want to do a bit of practice with rearranging the powers. So if I get rid of the negative power, the x goes into the denominator of the fraction, and then we can also rewrite that power as a third. With our last question, we've got 12x minus 6 in the numerator, and it's over the square root of x. Now remember, we talked about this before. When we don't have x's as individual components, we need to change it so that it is first before we can differentiate it. So we don't really have a rule at the moment if we've got a fraction with x's in the top and the bottom. Okay, likewise, we can't do anything with products. But that is something that we're going to come to a little bit later. Okay, so stay tuned for that. So first thing we're going to do is split the fraction. So I can write the 12x over the square root of x, like so, minus 6 over the square root of x. Okay, so if I have two things in the numerator that are added or subtracted, I can write them separately with the same denominator. What we're going to do with this is we're going to simplify that. If I've got x divided by the square root of x, I end up with just the square root of x. So think about if you've got x to the power of 1 divided by x to the power of a half, that's x to the power of 1 minus a half, which is just x to the power of a half. So that's the square root of x. So that turns into the square root of x. That fraction I'll just leave as it is at the moment, because what we then need to do is change it so that it's a power. So the square root of x is just x to the power of a half. 1 over the square root of x is x to the power of negative a half. Once we split it into those two separate powers of x, we can now differentiate each of those separately. So if I'm looking at this first one, I'm going to bring the power down. And what I've done is I've already multiplied it onto the 12. So 12 times a half is 6. And then I've taken 1 off the power. So half minus 1 is negative a half. For the second term, I've also done the same thing. So I've got negative a half. I'm going to multiply to the negative 6. So that's plus 3. And then when I minus 1 off the power, it's negative 3 over 2. So that would be your solution in index form. If we want, we can change it back into fractions and with surds. So if I'm working with the first one, that's 6 over the square root of x, okay, because it's it's the same one as that one, okay, so they look the same, so they're going to come out to be the same. When we're working with the second fraction, x to the power of negative 3 over 2 means that it's going to be in the denominator. The 2 in the bottom tells us it's a square root, and the 3 in the top tells us that we've got a cube on it. So what we're looking at here is a lot of questions where we're looking at how to differentiate. Now you might remember that 2 lessons ago we looked at tangents and normals. You can also be asked a question about tangents and normals for these questions. So it could be a question where I've got this graph and then it might say, I want you to find the tangent at x equals to 1. Okay, so what you would do is the same steps as from before. Okay, so the thing that we're practicing here is the differentiation. Everything that we've done with tangents and normals still apply in these situations as well.